Hello. In this video, I'll be going over the kinematic equations and their derivations in addition to some conceptual, explanations of them. So although there are sometimes 5 equations listed, I've always learned the kinematic equations as being a set of 4 equations. So that's what I'll be covering in this video. You'll see these in some different representations, but they're all the same in the end. This is just one way you can write them out. So the first equation I'm using is v equals v naught plus at. So v is velocity and v naught is initial velocity at time t equals 0, while a is acceleration. And it's important to note that these equations all apply to constant acceleration that is not time dependent. So the second equation is delta x equals quantity v plus v naught over 2 times t. Delta x is the difference in distance from where you start and finish after some time t, whereas v is the velocity at time t and v naught is your initial velocity. The third equation, delta x equals v naught times t plus 1/2 at squared. I've gone over all of those variables already, and the final equation is vf squared equals v naught squared plus 2a delta x, where vf is your final velocity. So to go over the first equation that I've highlighted in purple in the top left corner, you can derive it from really just starting with the equation a equals a, where a is acceleration, and I'll be doing these derivations using calculus. So let's start with that. A is dv dt, or that's basically your acceleration is your change in velocity over change in time. That's a common way to say what acceleration is. You can integrate both sides of the equation, move dt over, and because this applies to time-independent acceleration, acceleration is just treated as a constant here, so you can evaluate these indefinite integrals and get v equals some constant plus at. To actually solve for that constant, you just see what velocity equals at time t equals 0. So v of 0 is c plus a times 0, or v of 0 is c. So from there you can get that your constant is v naught, your initial velocity, and you arrive at the equation v equals v naught plus at. So for the second equation, I'm not actually going to be doing a mathematical derivation, but can just explain it verbally, because it's saying that the distance you travel is equal to your average velocity times time, where that's because v is your final velocity, so v plus v naught over 2 is just your average velocity during the time interval of t, because we're taking acceleration to be constant. So that second equation you can arrive at through a conceptual understanding, as really the other equations as well. The first one, your final velocity is just your initial velocity plus acceleration times time, so that's the additional velocity you gain over time t. So for this third equation, you can start with our first equation. I've written velocity as time dependent explicitly in this case, and we know that velocity is dx dt, or your change in position over time. From this, as before, you can move the dt over and then integrate. So v naught is time independent and can be treated as a constant here. whereas a is also a constant. So evaluating these integrals, you get x equals some constant plus v naught t plus 1/2 at squared. And we can then solve for what that constant c is by evaluating this equation at time t equals 0. And from this, you get that the constant is equal to x naught, your initial position. So continuing on, you can move the x naught to the left side of the equation, and delta x is just x minus x naught. So your final position minus your initial position is your change in position. So you arrive at the third kinematic equation. So for the last kinematic equation, we can once again start with the first. You can square both sides. This step is motivated by you knowing that there's a vf squared and a v naught squared, so at some point the velocities need to be squared. You can expand out the right side and then condense some terms together by pulling out an at from the last two terms. From this step, this is done so you can see a bit more clearly what's going on. I'm splitting the 2v naught into v naught plus v naught. And then from the first kinematic equation that we started with, we know that v naught plus at is just v. And from this step, we can multiply by a clever form of 1, that being 2 over 2, to make the equation be v squared equals v naught squared plus a times 2 v naught plus v over 2 times t. So I've just multiplied by 2 over 2, and I've also brought the t to the far right just to be able to see a bit more clearly that, as you can see by looking at the second kinematic equation, v naught plus v over 2 times t is just delta x. And from this, you can get the fourth kinematic equation because v is the same as vf, so final velocity. I hope that you enjoyed this video and that it was relatively clear. If you have any questions, please ask them, or if you have any suggestions for future videos, please comment. They would be much appreciated. Thank you.